The aims of this guidance are firstly to bring greater coherence to the national curriculum by exposing core concepts and demonstrating their progression from Year 1 to Year 6, and secondly to summarise the most important knowledge and understanding within each year group and important connections between them. This video guide summarises the knowledge and understanding that Year 5 pupils need to achieve by the end of the year in order to be ready to progress to Year 6. There are accompanying materials which provide teaching guidance for each ready to progress criterion and example assessment questions. We recommend that Year 5 teachers should read the guidance for both Year 4 and Year 5 so that they understand the starting point for Year 5 pupils. In Year 5, pupils need to extend their place value knowledge to include tenths and hundredths. Pupils should understand that 1/10 is 1/10 the size of 1, and that 100th is 1/10 the size of 1/10, and then conversely that 1/10 is 10 times the size of 100th, and 1 is 10 times the size of 1/10. Pupils should also extend the grouping and exchange model of place value to decimals and know that 1/1 can be divided into 10 equal parts, and each of these parts is called 1/10, and 1/10 can be divided into 10 equal parts, and each of these parts is called 1/100th. And Dean supports pupils to see the relative sizes of ones, tenths and hundredths. Once pupils have understood that 10 tenths are equivalent to 1, they should use this knowledge to work out how many tenths there are in numbers with ones and tenths values. 10 tenths are equivalent to 1, so 18 tenths is 1 and 8 tenths. And they should also be able to use the knowledge that 10 hundredths are equivalent to 1/10 to work out how many hundredths there are in numbers with tenths and hundredths digits. 10 hundredths are equivalent to 1/10, and 8 more hundredths is 1/10 and 8 hundredths. So pupils will understand these two different ways in which the unit of 1/10 relates to the unit of 1, the grouping exchange model and the scaling model, and in which the unit of 100th relates to the unit of 1/10, the grouping and exchange model and the scaling model. Pupils should also be able to combine tenths and hundredths units and say the name of the number they've represented, write the numeral in digits, and represent it on the Gatenio chart. Pupils should be able to decompose numbers using standard partitioning and use non-standard partitioning to decompose decimal numbers in different ways. This supports mental calculation, for example, subtracting 30 centimetres from 3.42 metres. As well as understanding the quantity associated with numbers, pupils need to understand the position of decimal numbers in the linear number system. They should be able to place them on partially marked number lines at a range of scales, for example, on number lines labelled with integers or labelled in tenths. Pupils should also make a reasonable estimation about the position of numbers on unmarked number lines. Teach pupils to mark midpoints to support them with this. For example, the midpoint of 3 and 4 is 3.5, and 3.42 sits about here relative to 3 and 3.5. Positioning numbers in the number system prepares pupils for working with scales on measuring instruments or charts, and helps pupils compare numbers and make estimates. Pupils should use their knowledge of where numbers sit in the number system to round decimals to the nearest integer, and round decimals to the nearest tenth. It's important that pupils understand that the point of rounding is to give an approximate value. Pupils should also be able to do this without a number line, and round to the nearest integer and the nearest multiple of 1/10. So pupils will leave Year 5 understanding these two different models of decimal numbers, number as enumeration, which is the cardinality of a number, and number as measure, which is its place in the linear number system. Pupils need to be able to decompose the unit of 1 into 2, 4, 5 and 10 parts. So 2 parts, 4 parts, 5 parts and 10 parts. And this helps pupils make connections between fractions and decimals. So this decomposition of 1 allows pupils to use common graphing units as well. Pupils should be able to complete and read scales marked in 2 parts, 4 parts, 5 parts and 10 parts. And pupils should be able to read values on partially marked scales, such as these values. So on a 2-part scale, 4-part scale, 5-part scale and 10-part scale. Finally, in number and place value, pupils should memorise common measures conversions like these ones. They should apply them to whole number conversions from larger to smaller units and vice versa. For example, knowing that £4 is 400 pence or that 8,000 grams is 8 kilograms. And pupils should also be able to carry out fractions and decimals conversions that correspond to some of these common 2, 4, 5 and 10 parts measure intervals. And this is shown here for kilometres and metres. And pupils should be able to extend these through the number system. They should, for example, know that 3 3/4 kilometres is the same as 3.75 kilometres and is 3,750 metres. Pupils should already have automatic recall of multiplication table facts and corresponding division facts from Year 3 and Year 4. The statutory multiplication tables check in Year 4 will identify some pupils who need additional practice. However, even pupils who are fluent in multiplication tables at the time of the check will benefit from further practice to maintain and secure their fluency. The multiplication facts to 9 times 9 and related division facts are particularly important, as these are the facts required for formal written multiplication and division. When pupils apply their knowledge of the commutative property of multiplication, this leaves 36 facts which are essential to master before the teaching of short multiplication and short division. As we've seen, in Year 5, pupils need to be able to work in units of 1/10 across the ones boundary. And pupils need to be able to apply this knowledge to their number facts by working in units of 1/10. So pupils know that 8 adds 6 is equal to 14, so they can reason that 8/10 add 6/10 is equivalent to 14/10 or 1 whole and 4/10. And the same idea of applying known facts to units of 1/10 applies to multiplication. 3 times 5 is 15, so 3 times 5/10 is 15/10, which is 1 5/10. Pupils need to extend their knowledge of multiplying and dividing by 10 and 100 from Year 4 into decimal numbers. 8 divided by 10 is 8/10, and 8/10 divided by 10 is 8/100. Pupils should continue to associate dividing a number by 10 with making a number 1/10 of the size, and multiplying a number by 10 with making a number 10 times the size. So 8/100 multiplied by 10 is 8/10, 10 times the size, and 8/10 multiplied by 10 is 8/1, 10 times the size. This includes calculation with numbers such as these. In Year 5, pupils should also extend their knowledge of factors and multiples, including using place value. For example, because 7 is a factor of 21, 7 is also a factor of 210 and 2100. And 210 is a multiple of 7 and a multiple of 3, but it's also a multiple of 30 and a multiple of 7. Pupils should learn to multiply multi-digit numbers by one-digit numbers using the formal written method of short multiplication. Pupils should understand that short multiplication is based on the distributive property of multiplication, which they learnt about in Year 4. And pupils should learn to divide multi-digit numbers by one-digit numbers using the formal written method of short division. Again, starting with simple cases so they understand how the algorithm corresponds to the structure of division. Pupils should be able to apply these written algorithms to numbers with up to 4 digits. In Year 3, pupils learnt to find unit fractions of quantities which corresponded to known times table facts, and they continued this in Year 4. In Year 5, pupils should be able to find non-unit fractions of quantities. So 1/5 of 40 is 8. So 3/5 of 40 is 3 times 8, or 24. And pupils should also be able to use short division and short multiplication to find fractions of larger numbers. Pupils should also be able to work out a whole given the value of part of a number. So if 1/6 of a number is 30, then the whole number is 6 groups of 30, which is 180. Pupils must understand that more than one fraction can describe the same portion of a quantity, shape, or measure. So the whole is divided into 4 equal parts, and one of those parts is 1/4. The whole is divided into 12 equal parts, and 3 of those parts are 3/12. Here, 1/4 and 3/12 describe the same part of this quantity as each other. And pupils should learn that 2 different fractions describing the same portion of the whole, like 1/4 and 3/12, share the same position on a number line, and they have the same numerical value, and they're called equivalent fractions. Pupils should learn to find equivalent fractions by using one of the multiplicative relationships within equivalent fractions. So the vertical relationship between numerator and denominator, or the horizontal relationship between the pairs of numerators or the pairs of denominators. Pupils know that both proper fractions and decimal fractions can be used to represent values between whole numbers, and they now need to learn that the same value can be represented by both a decimal fraction and a proper fraction, and be able to recall common equivalents, beginning with these unit fractions shown here. The work in number and place value on dividing 1 into 2 parts, 4 parts, 5 parts, and 10 parts will prepare pupils for relating fractions to decimals. Pupils should be able to extend these equivalents through the number system. So 2 parts, 4 parts, 5 parts, and 10 parts. In geometry, pupils should compare angles, including the internal angles of polygons, and they should be able to identify the largest and smallest angles where there's a clear visual difference. Pupils must learn that we can measure the size of angles just as we can measure the length of sides, and they should be introduced to the unit degrees and the symbol for it, and be taught to measure angles using a protractor. Pupils should also study area in more depth, and just as with angles where there is a clear visual difference in area, pupils should be able to compare the area of shapes without making a quantitative evaluation of each. For example, pupils can see that the circle here has a larger area than the decagon. Pupils should be taught that area can be measured using standard units, and pupils need to be able to find the area of shapes drawn on square centimetre grids by counting squares. And finally, pupils should learn that the area of a rectangle can be calculated by multiplying the length by the width.